I'm so glad to be here and share a little bit about drones, about Liferay, about AI, about low-code. But let's talk about a little bit about motivation. But we've seen a lot of examples using client extensions, using objects, and I would like to show you how can we use the powerful of Liferay to connect those stuffs. So with no ORCGI code, we can do everything using client extensions and objects. So, but why drone? Because I'm not drone enthusiast. And I'm a software engineer. I love to solve problems. Stay nerdy. I like to play with these stuffs. And one important point, the commercial drone market is projected to exceed $50 billion by 2025. The compound annual growth rate is 30%. So it's a promised market. There are many opportunities there. We need to explore. We need to connect with life. We need to leverage these opportunities. So what about applications we can build? You can integrate drones and Liferay, where we can use this kind of application. Farming. Drones are used to monitor crops, apply fertilizers, and identify pests boosting productivity and reducing costs. So many farms are using drones to do this. Industry. Drones can fly and inspect structures and equipment. So we can leverage this technology that allows inspections to be carried out without interrupting operations. And we reduce risk of an accident because it's not necessary to send people to these danger areas. So we can use drones, collect those images, store, process, use an AI, and support decision-making. Fire. We can map, track, forest devastation. We can use drones, using AI, using studying to do this. Police patrol. I could see in person, in Brazil, police headquarters, a drone plan, a drone operation, a real drone operation. The drone supports the people, the team on the ground, but they don't use it with expertise just to see images, but we need to leverage the technology, we need to leverage the AI to support, to make decisions. But how to implement this? Let's take a look a little bit on our architecture. So there is the Liferay, DXP, and outside Liferay, JVM, we have client extensions. So basically, we implement two client extensions, and both are object actions. One to fly, this fly object action. This client extension connects with the drone through a UDP connection. We open a socket, and we can send commands to the drone. We can read commands from the drone, and we can read the status from the drone. So we connect through Wi-Fi, and we can control the drone. So we implemented this client extension to connect directly to the drone. The second one is process images. So we leverage this, we implemented this and leverage this client extension to connect with Google Cloud Vision API. So using this, we can extract, we can process images, we can extract details, you can get details from images. So this kind of details will support our decision making. This is the client extension YAML file. So basically, there is a Spring Boot application, but we could implement using Python, using Node.js. But I implemented using Spring Boot, and I created some objects to store and connect to these stuffs. And there are just two object actions client extensions, Liferay/fly and image processor. Which drone we are using? This DJI Tello, this simple drone. We are using the SDK 2.0. It's a simple drone. It has some limitations like image quality, light, and radio interference. So I need your help. Because it's a simple drone. It's useful to validate, to run this POC, but we are able to integrate with professional drones that has API. So this drone has a SDK. So there are some examples of commands that we can send to it. So first of all, we send the string command to it. And this way, the drone enters in SDK mode. So from that, we are able to send new commands to the drone. First of all, we need to enable the SDK mode. So another example, take off, the drone auto take off. Land, stream on, I will enable the stream and connect it using another UDP connection. So basically, there are two connections with the drone, two different ports. When you send the commands, you another one to read the stream in process. And up, down, left, right, etc. And there is an emergency command. The drone stops the motors immediately. But sorry about that, I didn't implement that. If necessary, if I say emergency, please throw your tools on the drone and it will land automatically. But it's demo time. But I need your help, because there are some limitations with this drone, and please fasten your seatbelt and put your devices on airplane mode, because we need to prevent accidents, we need to prevent interferences, and the drone has to work on this stage. Please. I will show a little bit about our application. Okay, screen mirror. Okay, so here we have the vanilla DXP. I created this code here, this workspace, and there are two client extensions, one Spring Boot and one site initializer. I leverage this site initializer to create a site. So I declare here, I create some object definitions, like drone, flight plan, flight, in-flight image, in-flight image details. There are some object actions. Create an object folder to store the object definitions, and their relationships. So I just create this JSON file. I ran a GW deploy. I ran this site initializer client extension and created this website. So Liferay automatically. Okay, let's take a look on our object definitions that we created. So control panel, objects. Created this folder, Liferay. And let's take a look on the drone object definition. So there are some system fields, and I created a custom field to store the type text, to store the module, the name, the serial number, IP address, and an image as attachment. Flight plan, the same. There are some system fields, and we store all the commands in this field. So it will be a string, and each command will be separated by comma. The name of the flight plan, and there's a relationship with drone. So it's a one-to-man relationship. One drone has many flight plans. And in flight plan, there is an object action. I create this action fly. I create it as a standalone action. And as we deploy the client extension, we can choose here. So there are two custom client extensions. I choose this one. The flight. There are two basic fields, the name of the flight and the flight plan, another relationship, one-to-many relationship. A flight plan has a flight that has many flight plans. And in flight, there's another action too, to process images. It's a standalone action. We click on that button, we will trigger that CLAT extension, you process the images, all images from the flight. Flight image. So there is an images attachment. We store these images in documents and media. And there's a name. And the flight is a one-to-many relationship too. And lately, flight image detail. So we have the object that we identify using the Google Cloud Vision API. They score the object, the vertices that where the object was found in the image, and a relationship with flight image too. So let's take a look in our pages. So basically, there are 3 pages to show the drone collections, our home page. So there are 3 drones. We are using this Tello one, this Mavic Air, and others are just to illustrate some example. So when we click here in Tello one, we will read from the object entity, and we can display here. For that, I created some display page templates, like drone GPT. It's a display page template for drone. And we can map directly from the object definition fields for here. So we click on image, I map to preview URL, the image URL. The same for module, I map it to drone module. We can choose this one. Module name, IP address, and serial number are the same. So there's another page here. We can click on back. Flight plans. So there are 5 flight plans. Example here. If we click here, view, for instance, there's a name. There's the drone that we saved. The module IP address to use to connect using the UDP connection. And the commands. First of all, we will send the command take off. The drone will automatically take off. Flip right, photo, take a photo, flip left, take a photo, flip front, take a photo, flip back, take a photo, and finally land. Of course, we could create a UI to create this drone, these commands more easily. But just to illustrate, to validate this, we store these commands here, and we split and send each command. I will show the code, the CLAT extension code too. And the flights. So here, there are some examples. This is a flight. When we click, flight plan. When we click in fly, we will trigger an object action that we will connect with the drone, and the drone will run our flight plan, and it will run all the commands. So in flights, it's another display page template too. I map it using this collection display with each field. When you click in view, there's an example. When we click here, the image, we can see the objects that we identify. So that's another display page template. But here, we are using flight image, and this, let me see here, this collection display is connected with related items collection provider. Using that, we can filter by our entity. Otherwise, we will render all flight images. This way, you need to connect a related items collection provider to filter by our flight image. Okay, let's go back here. Let me share a little bit about the code. Let me close site initializer, the Spring Boot. Is it okay? Okay. Okay, so this flight class extension. When we trigger this class extension to fly, we invoke this method. We receive an object definition with the request body JSON. We transform into a JSON object. We can get the flight plan object, the ID, and post the flight. So when we click in flight, we will create a flight and store on using object. Then we will create a drone and connect with them. So this connect will enable SDK mode. Just send this command to it and turn on the stream on. So here we are using the FFmpeg frame grabber to read the video, and when we send the command photo, we'll take a photo of one frame from this using this socket. Okay. So from this JSON object, we will read all commands, split, and add each command to a command queue. Create an event listen here just to show, and then start the command queue. In the end, we will post all flight images that we collected. And if everything is okay, I will make sure that the drone will land, clear the images, and clear the command queue. Let's take a look on the flight. Okay. So here, we are leveraging this endpoint that it's generated by object. I just put the name of the flight and the relationship with the plan ID. Do a post and return the ID, because I will use this ID here to post the flight images. So the same, I will iterate each image, and I will post the flight image to document library, flight images here. Okay, so another class extension is to process the images. When we click and process image, we will trigger this class extension, and we will get the media, the photo from document media, and we will send to detect objects here. Okay. If there are images, we'll get images from the DXP, and we'll download and submit to Google Cloud Vision. So here we can, using a Google Cloud Vision client, iterate each image and extract the details. So here we can get the vertices, the object name, the score, and the store the vertices. And then we post to DXP using flight image details object. Okay. So let's try. I will turn on the drone. Okay. Where is the Wi-Fi? Okay, Tallow. Okay, carefully. I'll put it here. Move away. Let's choose a flight plan. Let me see this flight plan 1. Yeah, looks good. If I click and fly, oops, Need to start the client extension. GW boot run. I'm in the correct branch, yes. Okay, when clicking fly, I will connect with the drone. Okay, oh. Take some photos. Come down. Final land. And here, thank you so much. Here in flights, let's see. Yeah, today. Oh, the audience. As I said, the image is not good. It's poor. The quality is poor because the light. But I have one real image here. It's not that. I capture outside with the drone, and it's a real image from the drone, and we could identify the objects. So here at flights, flight plan, this one. I can click in. Let's run on another flight plan because I have no internet connection for now because I'm connected with the drone. Let me reposition. Okay. Here. Let's see this. I was training tonight. It's my role at the hotel. Let's take a look in 5. No. 3. Yeah, this one's interesting. Flight 3. Let me double check here. Okay, rotate, take a photo. Rotate, take a photo. More photos. Land, please. Okay. Oof. Thank you so much. And here, we can see more images from the audience. Oh my goodness, it's so high. Yeah, but all images are stored on document library. Yeah. So if I click here, let me turn off with the drone. I connect with our Wi-Fi, and now I have internet. So if I click here, in this flight in process image, let me see here, okay. If I click here, I will send to Google Cloud Vision API and try to detect. But I think because the poor of the quality of the image, we don't have things to process. Let me double check. I have it, okay. Okay, start object detection. Meanwhile, I will show you all images are stored in documents and media. So we have here all images. Yeah. So for, let me see, flight plan, this flight. I have just one image, so I will get this one. Flight image. we can add. Let me test this. Yesterday I was training, so I will use this, because I took this photo with my cell phone, because the light is better. And flight, let me see the better flight to test. Okay, it can be flight 1. Where's the flight 1? No. Here. Okay, so I will submit again the process images. And then we have results, because the quality image is better. So here, when we click here, we can see the laptop, the bottom, the tabletop, the computer keyboard. So the Google Cloud Visual returned for us all details that we have on this image. Let's go back to here. Oops. Let me turn it off. Yeah, guys, I'm so glad to be here, and I will be glad to talk to you. If you have some questions, please reach out to me, and I will be glad to share with you. So for that, thank you very much. Enjoy the Devcon.